Hi, welcome to Coding Droplets and thank you for watching this video. This is the first video of .NET MAUI tutorial series, and in this video we are going to see the .NET MAUI installation and initial project overview. You can find the playlist link of the series in the video description. First, let's see what is .NET MAUI. MAUI stands for Multi-Platform App UI. .NET MAUI is a cross-platform framework for creating native mobile and desktop apps with C# and XAML. Using .NET MAUI, you can develop apps that can run on Android, iOS, macOS, and Windows from a single shared code base. .NET MAUI is an open source and is the evolution of Xamarin Forms, extended from mobile to desktop scenarios with UI controls rebuilt from the ground up for performance and extensibility. If you have previously used Xamarin Forms to build cross-platform user interfaces, you'll notice many similarities with .NET MAUI. However, there are also some differences. Using .NET MAUI, you can create multi-platform apps using a single project, but you can add platform-specific source code and resources if necessary. One of the key aims of .NET MAUI is to enable us to implement as much of our app logic and UI layout as possible in a single code base. Supported platforms. For .NET MAUI apps, the supported platforms are Android 5.0 API 21 or higher, iOS 10 or higher, macOS 10.15 or higher using Mac Catalyst, Windows 11 and Windows 10 version 1809 or higher using Windows UI Library 3. For .NET MAUI Blazor apps, the supported platforms are Android 7.0 API 24 or higher is required, iOS 14 or higher is required, macOS 11 or higher using Mac Catalyst. .NET MAUI Blazor apps also require an updated platform-specific WebView control. .NET MAUI apps for Android, iOS, and Windows can be built in Visual Studio. However, for iOS development, a networked Mac is required. .NET MAUI also includes Tizen support, which is a Linux-based mobile operating system by Samsung. To use .NET MAUI, you need Visual Studio 2022 17.3 or greater. I'll just show you how to install MAUI in your machine. Here I have opened Visual Studio Installer and you can see I already have Visual Studio 2022 with version 17.3.5. If you have a version lower than 17.3, you must update Visual Studio. Now let me click on Modify button and it will show the available components that we can install. Here under Desktop and Mobile section, we have .NET Multi-Platform App UI Development. Let's select that. Now we can just click the Modify button and Visual Studio Installer will start downloading the needed files and install .NET MAUI in our machine. This process will take some time, so I'm just skipping this part. So now the installation process got completed. Next, let's create a sample MAUI project and see how the project looks like. I'm opening Visual Studio and let's create a new project by clicking on Create a New Project button. Here we can choose the .NET MAUI project template. To search easily, I am clicking on the project types drop-down list and now we have a new option named MAUI. Here we can see three different project templates: .NET MAUI app, .NET MAUI Blazor app, and .NET MAUI class library. Currently, I am selecting .NET MAUI app and we'll discuss about the other two options in a later video. Let the project name be Sample MAUI app. Let me also place the solution and project in the same folder. Then here we can select the framework. I'm using .NET 6 framework. Now clicking on the Create button, Visual Studio is creating the project. The project got created and we can see the project files in the Solution Explorer. It is showing some warning messages in the Dependencies section. Still, some processes are running in the background. Let me try rebuilding the project. Build got succeeded and the warning messages disappeared from the dependencies. Here you can see the project is having dependency libraries for Android, iOS, Mac Catalyst, and Windows. Inside the platforms folder, we can see the platform specific files. We'll be going in detail about all these in an upcoming session. Android folder contains resources, Android manifest file, main activity class, and main application class. iOS folder contains app delegate class, info plist file, and program.cs. Mac Catalyst also have similar files like iOS. Tizen folder contains 2 files in it. Finally, Windows folder, it contains 3 files in it. We also have a resource folder here. The resources in this folder will be shared among all the different platforms. App icon folder is having some SVG files. I am just opening one of the files. You can see the file content. Also, there are 2 font files in the fonts folder. Then images, raw, splash, and styles. We'll go through all of this in detail in the upcoming videos. Next, let's open Mawai.cs file. This class enables apps to initialize from a single location and provides the ability to configure fonts, services, and third-party libraries. Android, iOS, Windows, and all platform entry point calls the create Mawai app method of the static Mawai program class that creates and returns a Mawai app while launching the application. Here you can see the font files which we have seen in the fonts folder has been configured. Let's move to XAML files now. XAML allows developers to define user interfaces in .NET Mawai apps using markup rather than code. For each XAML files, you can see a class associated with it in which we can implement the C# code. Here we have app.xaml.cs, appshell.xaml.cs, and mainpage.xaml.cs. Inside app.xaml file, we can see a parent application tag, and inside that, 2 files are configured as the application resources. Don't worry, we'll discuss about resources later. The app.xaml.cs class is a partial class which is inherited from application, and there is just a constructor in which initialize component method is called, and a new appshell object is assigned as the main page. From here, we can change the main page of our application. So let's see what are there in appshell.xaml file. It contains a shell parent tag, and inside that there is a shell content tag. .NET Mawai shell reduces the complexity of app development by providing the fundamental features that most apps require, like a single place to describe the visual hierarchy of an app, a common navigation user experience, a URI-based navigation scheme that permits navigation to any page in the app, an integrated search handler. The appshell.xaml.cs is just calling initialize component method in its constructor. Next, in mainpage.xaml, we can see the parent tag is content page. A content page is in which we design the page. Content page displays a single view which is often a layout such as grid or stack layout. In a .NET Mawai app, we can create multiple content pages and we can perform navigation between these pages. Here you can see there is a scroll view in this content page, and inside scroll view there is a vertical stack layout. Inside that layout there are several elements like image, labels, and button. In the main page.xaml.cs there is a private method named onCounterClicked which will be called on the button click. Let me run this application so that you can see how this sample app works. To run this in Windows machine, we must enable the developer mode in Windows settings. We can just click Settings for Developers and it will open the settings window. There we can just enable the developer mode. Now Visual Studio started building the app and it is running now. So we can see the image, 2 labels, and the button. When we are clicking the button, it is showing the count. Next, let's see how we can run the app in different platforms. Here inside Framework, we can see .NET 6 Android, iOS, Mac Catalyst, and Windows options. Let me select Android now. As there are no Android emulators installed currently in this machine, Visual Studio will open Android Device Manager and we can add a new emulator. Let me click on the Create button, then accepting the license agreement. Now it is downloading the needed files and it will take some time to complete. Now emulator creation process is completed. We can just click on the edit button to view the properties and edit it. I'm not editing anything. Let me click the cancel button. Now let's start the emulator. The emulator is getting started and the application will get deployed in the emulator once it is started. The app is running now, so you can see the button click event is working in the same way. Here we have XAML live preview in Visual Studio, which is also showing the live screen. Now I just need to show you how we can modify the XAML file while app is running. I'm just changing the hello world to coding droplets. The changes are getting reflected immediately in the emulator. Let me also change the other text. That one also got changed in the emulator. Let me assign a background color for the button. You can see the change in the emulator as well without rerunning the project. But if I'm stopping the application and open the deployed app from the emulator menu, the modification whatever we have done while running the app has been reverted. For the changes to be updated in the deployed app, we must run it again. Now the app got deployed again in the emulator. So now if I stop it and open the app in emulator, we can see the new changes. Now if you need to uninstall the app from the emulator, we can remove it in the same way as we do in an Android phone. You can see it got removed. Now let me close the emulator. We can also run the app in iOS platform. But here you can see it is mentioned as remote device. We need a Mac in the network to run the app in iOS. If I click this, it will first build the project and then it will ask me to pair a Mac. Here we can see the steps to pair a Mac. We can click on the Add Mac button and provide the Mac name or IP address. Hope you are clear with running the projects in different platforms. So that's it for this video. See you all in the next video. Thank you.